last lesson. Thank you, ladies. Let's get into it. Come on. Last lesson we looked into recurrence relations, obviously, but now with geometric sequences, or if you think about it, compound interest, where you've got when you're multiplying instead of adding or subtracting by the same amount. Okay, some principles to remember is that if you multiply with a number greater than 1, it's going to increase, and if it's less than 1, it's going to decrease. Also note how we find that R value. So this new R value here, okay, we've looked at it before. If your R value is increasing, try and reset this. If your R value is increasing, okay, then that means you use the plus, 1 plus. And if it's decreasing, which we'll get into a little bit later, 1 minus the R over 100.
If the R is like 0.001.
Well, if you read the question and it says, oh, it is depreciating,
Okay.
then you use minus. Oh, this one is saying, oh, it's an investment and it's increasing, so it's plus. Also, the other thing that we need to look at, examine is part D of these questions will ask you to prove that the interest rate was this. So the interest rate formula that we used, so normally this is the rule to find the R value. But if you want to find the interest formula, the interest rate, sorry, we use this formula. Okay, that's if it is increasing. If it's decreasing, which we'll see in a little bit later, it's slightly different. Okay, but similar. Okay, so I know that I didn't provide a formula sheet for these notes, but yeah, you'll at least you'll have it in your notes at least. Okay, so if it's asking you to prove the percentage, use this formula if it's an increasing type geometric. Okay. All right, let's keep going to the next part. So generally, when we've worked with these questions, and you look at the R value, so you've always used this formula, yeah, to find the R. So it's R equals 1 plus the percentage over 100. Now that's for finding the common ratio, but for compounding periods. Okay. Now generally, if you look at the question, it's pretty straightforward. It's pretty simple. Okay, but sometimes this is because, you're compounding only once a year. Okay, you remember that last lesson? I mentioned the words weekly, fortnightly, daily, quarterly. That description of those words are now going to come into play because this is when the interest rate, okay, is compounded more than once a year. Sometimes it'll be twice, quarterly, 3 times, or daily, okay, or weekly. And when that happens, we need to add one little thing to our formula. You guys see that? We're going to divide it by the number of compounds. So instead of R equals 1 plus the percentage over 100, if you're compounding more than once, okay, you need to divide that percentage by the number of compounds per year.
You're compounding more than once.
So normally, if it's yearly, we just leave it as it is. So if it's just once,
If it's more than 1 year.
if it's more than 1 year, you have to divide that percentage over the whole year for the number of compounds. So if you're compounding monthly, okay, that means you're going to divide by 12. That x changes to 12. If you're going to compound daily, that means that x will be 365. If you're going to compound weekly, it'll be 52. If you're going to compound biannually, that means twice, so it'll be divided by 2. Okay, that's the only thing that's changed here. It's just if it's different compounding periods, you have to add this divided by x in here. Okay, does that make sense?
Yeah.
That's pretty easy. Okay, so I'll just leave that there. So instead of just having this on its own, so the percentage, if it's annually, it's fine. But if you're compounding more than once a year, then it's going to be the rate divided by whatever it is compounding. So it could be weekly, daily, depends on the question. So this is where you have to really read the question and understand what it's telling you to do. Okay. And nothing else has really changed. Yeah. So you've still got VO, and it's just going to be the R or the common ratio multiplied by whatever term you're looking for to find the next term. All right. So let's try and do these ones. Okay. We're going to try and figure out what's the rate or the big R if it's compounding at different periods per year. So we need to write a recurrence relation. So remember, your recurrence relation is just your instruction. So it looks like this. So V0 is starting term. And then you got to tell me, how do you get the next term? Vn plus 1 is equal to Vn times R. I know that in the previous examples, it's R times Vn, but it's the same thing. Okay, I like to write Vn times R instead. Okay, so that's what our recurrence relation should look like. So let's look at part A. Part 1. So it says here, Oliver spends $800 on his credit card and the bank charges him 20% compound interest per annum. But in the second part, it says, write the recurrence relation, correct to 3 decimal places that models his debt of his credit card if it compounds annually or monthly and quarterly. So already, the X value for monthly should be 12, and for quarterly, it'll be 4. Okay, so just remember that when you're trying to find the R. So remember that R formula, if it's compounding more than once, it's going to be 1 plus the percentage rate divided by the number of compounds over 100. Okay. I'll use N. I know that hopefully that doesn't confuse people. I know the formula here I think uses X, but I think later on it uses N as well. So just remember what this represents, yeah? The number of compounds. The other one. Alright, so let's find the first one. I can already tell that the first one, okay, V0, starting term, just read the question, it says 800. So he starts off with $800. And then Vn plus 1 is equal to Vn times. Okay, now we find the rate for it. So using my formula, R equals 1 plus the rate that he's being charged is 20%. So 20 divided by the number of compounds according to this is monthly. So that N has to be 12. And then divide that by 100. That means the R value for this one. Alright, I'll just put this here so you guys can see it still. R value for that one. Let me get rid of all this. Okay, so the R value for this is going to be 1 plus. You can use your fraction button if you like. I think actually it's worth using the fraction button here because the formula does get a bit complicated. So divided by 12 and then down here divided by 100. So that, and if you get a fraction, press Control Enter, and it's 1.01667. It doesn't tell us to round 3 decimals, so it'll be 1017. Okay. So 1.10. Oh, sorry. 1017. Okay, so that means 1.017. Okay, so that's it to 3 decimal places. Nice and easy. Okay, and then if we were to do it for part 2, where it says it's compounding quarterly, okay, so quarterly, it's going to be the same V0, so V0 doesn't change. It's still 800, except now the compounding interest is different. So it's Vn times, so instead of 12, we're going to go R, so let me just put a line here. 1 plus 20% still, divided by, instead of 12 though, it's quarterly. So 4 divided by 100. So on my CAS, just use the same one, but instead of 12, it's going to be 4. So Control Enter, and that equals 1.05. Okay, 1.05. Notice how the less frequent you are compounding, the higher the interest rate, but the more frequent you are compounding, the lower the interest rate, yeah? Just keep that in mind when you do these questions. Okay, next one. Find the amount rounded to the nearest cent that Oliver owes of his credit card after 6 months. Okay, so we're just trying to find now what would the value be after 6 months using either of these formulas. So for part A, remember that the recurrence relation is this, so you're multiplying by 1.07. So let's do that on our CAS. So after 6 months, I'll just write that here, V6. Using your calculator for this. Okay, so it starts at 800. Okay, good. So we start at 800, and we're multiplying by 1.07. So times 1.017. Sorry. So there's year 1, year 2, year 3, year 4, year 5, year 6. So 885.148. It doesn't tell us nearest cent. So 885. Oops. 0.148. So we'll round it to 15. That's the nearest cent. So that's the 6th term if he's compounding monthly. So that's the first one. And for the second one, we're going to use the second recurrence relation, which is this one for part 2. Okay, so we're looking for V6 again. Okay, so similar thing, except this time you're multiplying by 1.05 instead of 1.07. So it's going to be 800, sorry, starting term, multiplied by 1.05. So that means it's term 1, year 1, year 2, year 3, year 4, year 5, year 6. So at year 6, it's 1072.08. 1072.08. Or after 6 months, so that's quarterly.
Wait, so the nearest cent, so it'd be...
Oh, sorry, did I not round it? Yeah, 0.8, so 8 cents. Yeah.
Wouldn't you put like...
$1,072.08. Yeah. It's alright, Shh. Alright, let's keep going. So, next part now. Same thing, I would say these questions, actually, do we want to keep going with the same type of examples, or
Factoring, we get it already.
do you get it? Yeah?
Not difficult.
These are the same ones, I think.
Let's get different. Let's speed it up.
Okay, actually, I'll be a butt and try one of these for you guys, okay? Just one. So we'll do A part 1 and B part 1. Because, actually, we'll do A part 2 actually, and then B part 2. Because the periods here are slightly different, okay? So let's just do A part 2. Okay, and we'll do A part 1. So for the recurrence relation, remember just write V0. That's really easy. You know it's 4,000. I don't even have to read the rest of it. I know that that's where it starts. But in the exam, in the SAC, just make sure you double check to make sure. But I can tell, reading the question, 4,000 in a hedge fund earns 9.5%. Okay. So you know that the R, so to find the R for this, it's going to be 1 plus the percentage rate divided by the number of compounds. So if you read the compounds for this, quarterly, it's 4. Okay, divided by 100. Okay, so the percentage rate for this is 9.5 divided by 4 over 100. Okay, so let's put that in our case.
So where do you find the
Which one?
think on?
Which one? The 4?
No, the
Formula? Percentage.
on the CAS, the
Divide.
yeah.
Control. Divide. To do the fraction.
Yeah,
To do the fraction. So 1 plus control divide. That'll give us a fraction. So it's 9.5 divided by 4 over 100. So that'll be... Oops, what did I do? Oh, there's a space there. Okay. 1.0237. So I think it's 3 decimals again. Yep. So 1.023. That's 7. We'll make this 4. So there's my R value. Okay, easy. Now, B. So this part here, guys, you have to read the question properly, because this is, again, how they differentiate the people who read the question properly to those who don't. What is the value of Phoebe's investment after 6 months? Okay, but it's compounding quarterly. Have a think about, if you're compounding quarterly in 1 year, how many months has gone past if it's quarterly?
3.
So if there's 3 months, so that means if you're compounding after 6 months, how many times has it compounded? Twice. Okay, because if you're compounding quarterly and it says, oh, how much after 6 months? If 1/4 of the year is 3 months, so 2 quarters would be 6 months. So it's compounded twice. So that means we're actually looking for not V4, we're looking for V2 because it's compounded twice. Okay, you have to read the question properly because it'll pull that out on you.
So why don't we do that for the previous one?
Yeah, I think I didn't read that one properly. But technically, okay, that's what will happen in the questions if you don't read it properly. So I didn't read it properly. But that's why I did this one again.
True.
Alright, so now no one caught that.
Yes.
But now you do. There, lesson learned. 4,000 and you're looking for the second term. Okay, multiply by 1.024. So term 1, term 2. 4194.3. So take it as a learning curve. Okay, sometimes these are the things that will happen if you don't read the questions properly. Okay, you want to make sure you read it. And yeah, people will make that mistake sometimes if you don't read it.
Wait, so what do you do then?
So if you read the question, if you're compounding quarterly, okay, that means it's every 3 months you're compounding, yeah?
Yep.
So if you read the question here, how much compounds is it after 6 months?
Yeah, so 2.
It'll be 2 compounds. So you're looking for second term, not the fourth term.
How do you get that 4194?
Oh, well, my calculator, I worked it out recursively. So if you start at 4,000 and I multiplied it by the R value,
Oh,
there's second term, and then there's first term, sorry, and then the second term.
oh.
All right. All right, let's keep going. So reducing balance versus flat rate. This is basically just going to point out the difference between flat rate depreciation. So similar to last time, how with flat rate you're just minusing or adding by the same amount. You can see here it's minusing 1,000 each time. Okay, minusing 1,000 each time. But for this one, okay, if I without calculating the R value, can anyone tell me what are you multiplying each time to get the next number? If you look at it, it's a 10% reduction. So what's the R value going to be? 0.9. Good. Elion. It's multiplying by 0.9. You guys see that? Okay, because it's a 10% reduction.
Wait, what?
Yeah, so what are you multiplying by to get the next number?
0.9, but why is it 10%? Why is it 0.9? Why is it not 0.10?
Well, if it's 0.10, that's a 90% reduction.
0.010.
0.010 would be a 1% reduction, or a 99%.
So what is it then? What?
It's 0.9, because if you times by 1, what do you get? It's the same number, but if you're reducing it by 10%, okay, what are you multiplying it by to make it smaller?
0.9.
And if you're increasing it by 10%, 1.1. Okay.
10%.
Alright. See the difference as well with a compounding reduction or reducing balance. It's going to be a curve, but if it's going to be a flat rate, it's a straight line. Okay, just notice the difference. Okay, now this is a same thing, but it's just reducing now instead of increasing. So the previous ones we were doing all just increase. This is all just decrease. Okay, I think you'll find with the questions that I looked at here, they're all going to be compounding once a year only. There's no like monthly or quarterly questions here. Okay, they're all just per year. Now, I don't know why, but they've just left it as per year, so we'll leave it at that. It's the same thing. Okay, remember the principle. If it's increasing, it's plus, but if it's decreasing, it's minus. Okay, decreasing, it's going to be minus. And to find that R value, it's this formula. Okay. And also, if you're trying to find how much it's gone down by or how much it's depreciated by, find the get the current amount and then minus it with the original amount, and you'll get how much it's gone down by. Okay. All right, let's go here. Oh, also note that on part D of these questions, remember in the previous one, I gave you that formula to find if it's a percentage increase, and you got to prove the percentage. Use this formula. Okay, but when it's decreasing, it's slightly different. Okay, let's do this. So using recursion, show that the value of the tractor after 2 years is this. So easy. Let's do that. Using recursion. So we know that T0 is 45,000. Okay. So T1, looking at my recurrence relation, is going to be a T0 times 0.865. Okay. So that would be T1 equals 45,000 times 0.865. So on my calculator. So 45,000, start with that, multiply by 0.865. Okay, so term 1 is 38925.
Taking joules.
Okay, so that's the term 1. Term 2, okay, will be T1 times 0.865. So term 2 would be 38925 multiplied by 0.865, and on my CAS should make sense that that equals 336701.
This is going down, right?
Yes,
Depreciating. No, it's depreciating.
correct. So this is depreciating. Same thing, it's just depreciating now. Okay, not much of a difference. Okay, part 2, B, sorry. B here is find the value of the tractor after 4 years. So I've started my recurrence relation. So we're looking for term 4. So just use your calculator to do that. So I've already got term, let me get rid of these so people don't get confused. Oh, oops. There's already term 1, term 2, to term 3, term 4. Right there. So T4, 25192.8. Okay, so that's the value of term 4. So the next one, part C, at the end of which year is the tractor worth no more than 20,000? So at what year will it be no more than 20,000 or less than that? So it can't be higher than 20,000. Okay, so for part T6, you reckon? Well, let's have a look. So that's T4, T5, correct, T6.
Also, a love one.
So at the 6th year. So I would write that here, at the 6th year. It will be worth. You don't have to write. You can technically, if you just wrote the 6th year, I'd be happy with that. But in year 12, they do want you to be very, very precise with it. So 18849.9. Okay, that's how much the tractor will be worth at the 6th year. Okay, and in part D, so this is where now you have to prove that the percentage rate is 13.5. Okay, now to do that, instead of using the other formula that I showed you before, this one's slightly different. Okay, so remember to find the R value, if it's decreasing, yeah, it's going to be 1 takeaway percentage over 100. Okay, but to prove the percentage, what you're going to do now, instead of what I wrote here previously, where was it? Okay, so instead of using this formula of rate minus 1, okay, it's going to be slightly different.
Rate minus 5.
Plus 1.
Ooh, close. It's going to be the other way around where you go.
Oh.
1 take away the rate times 100. So it's just flipped around.
So wait, is this for depreciating, right?
Yes, only for depreciating. Okay, that's the only difference. So yep. So if we try to work that out, Elion, it'll be 1 take away. What's the rate? What's the big R here? Sorry, 0.0875.
No, it's 0.865.
65. Sorry.
Minus 1, it will make it 0.0.
That's right. Times 100. So we're trying to prove that the percentage rate was 13.5. Yeah. So that would be calculator 1 takeaway. Oh, let's put it in brackets. Always put in brackets for these ones. 0.865 multiplied by 100, and it should equal 13.5. So the percentage rate is definitely 13.5.
This looks like a button.
There is a lot, isn't there?
Go.
Okay. Yep. Oops, sorry. How to write your recurrence relation. Everybody, we've done this many times already. Let's just do one as an example. Okay. Shh. Thank you, ladies. So first one, let's just do the first one. Writing a recurrence relation with these questions. It's after. So we're going to skip this example of Rachel buys a truck and just go to this one. Alright, so writing your recurrence relation, just make sure you're mindful of the V0. Elion, shh, thank you. And also mindful of the percentage rate. Also, because this is reducing balance, okay, that means you're going to use the R minus 1. Okay, oops. R equals 1 minus percentage over 100. Okay, V0, you know it's 38,000. And then Vn plus 1 is equal to Vn multiplied by, let's find that R value. So R equals 1 take away 15.25 over 100. So R equals minus, correct. 1 take away. You can use your fraction button if you like. 15.25 divided by 100. And that R equals 0.8475. And that's it. That's for writing your recurrence relations. For reducing balance, yeah. Really easy. Alright, any questions? I'm going to leave it at that for now and let you guys work.